Hello, I'm Antonio Torralba, and I want to talk to you about how do we teach computers to see. What we want is we want to build systems that are able to process the visual world just like humans do. We want systems that can understand the objects that they have in front. For instance, one example of a task that we want to solve will be something like you have a picture like this one here, and you want the system to be able to tell you all the different objects that compose the scene. You want to label every single pixel and tell you this is the road, this is the sky, there is a person, a car, and so on. And there has been an enormous amount of progress of solving this task. There are many other visual tasks that you want to solve, but this is one important example that is one of the core areas of research in computer vision. And the way in which you solve this task, you use machine learning, like deep learning, but one of the things that you need is you need to train your system. You need to teach the system to solve this task. And in order to do that, what you do is you have pairs of examples in which you have an input and the desired output. And you have to provide to the system with lots and lots of examples that look just like that. And you need hundreds of thousands of those examples in order for the system to learn, to make that association. So how do we do that nowadays? Well, with crowdsourcing. You hire a bunch of people, you put them in a room, and you don't let them out until they finish labeling all the images. And that's how you teach the systems to see. And they are starting to work pretty well. There are some really amazing results out there. But this is kind of unsatisfying, no? Because this has nothing to do with how we do learn to see. In fact, the way that we learn to see is in a much crazier environment. It doesn't have a lot of structure. So let's see an example of a kid learning to see.
In the summer, I like to lie in the sun and watch the birds. And I like to watch the frogs in the pond. Then I curl up in my hollow tree and dream about spring. The end.
So just like machines, kids also need a lot of data, and they don't like it when you stop giving them data. But look at this environment. This is really amazing, because the kid needs to learn what an object is by just looking at these pictures, and the supervision, how the parent is teaching the kid to see, it also comes in a form that is also unknown for the kid, because it's in the form of a language that the kid also doesn't know how to interpret. So both the thing that is trying to learn and the supervision, the supervision that is getting, both come in an encoded form, and it has to decode both simultaneously. So it's a very challenging task. And this is one of the things that we are trying to do. So one of the things that is really interesting when we tackle problems like general AI and so on is that it's not enough with the research that is done in a single lab. We need to really bring expertise across different labs. So what I will show you is have two glimpses of efforts in which we try to solve this problem. So the first one is in collaboration with the speech group, and is in the part of the thesis of David, and also his supervisor, Jim Glass. And what we are trying to do is to have a system that can learn both to identify objects and to understand the words that come with them in a very similar setting to the one that I just played before. So what we will be images like that, and we just ask people to give verbal descriptions of what they see. They don't need to come in any structured form, just talk about the picture. So let's watch one example.
This is a photo of a girl standing in front of a lighthouse. The little girl is wearing a blueprint dress. She has blonde hair and blue eyes. The lighthouse in the background is white with a red roof.
So David collected hundreds of thousands of pairs of images and descriptions of the content of the picture. And there were no specific instructions. People just had to talk about the content of the picture. So now the challenge is, can we build a system that will be able to identify both objects in images and words on the raw speech signal without any additional supervision? So the input will be images with pixels, and the system really doesn't know which pixels to correspond to an object, and then the raw audio signal that you hear from the speech. So again, this is something that doesn't really tell you where a word starts and where it ends, what a word is, and what are the pieces that actually refer to the content in the picture. So we want to build a system that is able to put these things together and find the correlations. So I won't go into the details of how it works, but basically the system doesn't learn with any additional supervision. It just takes as input both the set of images and the associated raw audio signal that goes with it. And the output of the system is the discovery of groups of pixels that seem to mean something, they seem to go together, it's an object, and pieces of the speech signal that seem to refer to those. So I'm just going to show you what the final output of the system is once it has been trained to solve this task, so that you can see how it actually has learned to recognize objects and words. So what I will do is I'm going to play the audio, and the system will highlight the regions in the picture that seem to correspond to different pieces of the speech signal.
This is a photo of a girl standing in front of a lighthouse. The little girl is wearing a blue print dress. She has blonde hair and blue eyes. The lighthouse in the background is white with a red roof.
It isn't perfect, but it's quite amazing that it's been able to learn this from that unstructured type of input data. And it's just wonderful to look at many examples like that. It's just amazing how it's able to locate words and objects in pictures. So let's look at a few more examples.
Here we see a stretch of grass and a small road leading up to a very old ancient ruin.
Here in this picture, there's some skiers going up a mountain.
So the system has been able to put together pixels in the picture, recognize that this must be some object that appears over and over again, and it seems to be related to a particular piece of the speech signal. So this is a really interesting setting in which now you are able to learn in a way that doesn't require the same type of manual supervision with detailed annotations as we had before. But still, kids get to learn in even crazier environments. So by many times, the kids actually don't even need the parent with them to learn. Most of the time, they are just playing by their own, touching the wall, seeing how it feels, and so on, and they also learn without the need of a parent. So let's watch a kid learning by its own. Just playing, touching things, hearing the sounds that it makes, and then just put it in the mouth to get the final bit of information that you need, just to make it all worth it. So what is really interesting is that this kid is learning, is playing with the world because he's actually learning about it. And it's the combination of all the different sensory modalities that give the supervision that you need in order to also discover that there are things in the world that they look in a particular way, that they feel in a particular way, and they make a particular set of sounds. So it's through these interactions that you also get to learn a lot about the visual world. So in particular, what is interesting is that this system is actually self-supervised. It's teaching by itself to discover what the world is all about. So in fact, when you are in the world, you are always listening to it, you are hearing noises, and what you hear and what you see is also correlated, just like when we were watching these images with descriptions of the content of the picture, the world is actually also describing itself without no one having to talk about what the content is. You are in the street and you hear the noise of cars. And it's only when you see a car that you hear the noise of a car. People talk and they make special noises, and there are all kinds of objects in the world, and all of them are making their own type of noises. So if you think of those just as speech signals, you can also try to discover what are the sounds that you hear in the world and how do they correlate with the visual world. And by doing that particular correlation between these two sensory modalities, you also get to discover objects in the world. So that's another collaboration also with the Brain and Cognitive Science Department, with Josh McDermott and other PIs at the Computer Science Laboratory and Artificial Intelligence Laboratory. So this is the type of videos that we will use to learn. So you just see some particular setting, and you hear the ambient noise that goes with it. And the nice thing is that you can now have the system just watch all kinds of movies and learn from them without no one having to actually provide any supervision. And there are lots and lots of copyright-free movies out there, and when you watch them, you understand why they are copyright-free. So we just had the system to watch all these movies. And what is the result? The result is that the system will also learn to correlate different types of sounds with what you see. So here's an example of images, and it locates the sound, which pixels in the image might correspond to that sound. It doesn't know what people is. It only knows that people make this sound. So which is basically just missing the word people. It already knows how to detect them. So building systems that can learn by themselves will open us the possibility of having machines to learn to solve tasks that maybe we cannot even provide supervision because we don't know how to solve those tasks. So artificial intelligence is going to require better understanding of how humans learn to recognize the world. So, thank you.